Okay, so now we already have 38 students. So I think that maybe we can start the class. So for Muslims, we can start the class by reciting Al-Fatihah. Okay, so semua tahu kan kos ni pasal apa sebenarnya? Telah di-brief oleh Dr. Syazwan. Hello?
Tak di brief lagi.
Oh, okay. Belum di-brief ya? Okay, macam ni. Course ni kita panggil instrument competency. Maksudnya, by the end of this course, you should be competent to handle the instrument. Okay, so dalam course ni kita akan, apa orang kata tu, kita akan belajar dari segi teori juga, yang mana teori itu you guys dah belajar ke dalam instrumental analysis? Contohnya macam dalam kes saya akan handle GC, gas chromatography. So you guys dah pernah belajar pasal gas chromatography? Eza? Nur Ezatul?
Ya,
You guys dah pernah belajar ke pasal gas chromatography?
ada pernah belajar and sekarang pun akan belajar lagi.
Oh, yang sebelum ni dalam subjek apa? Kalau boleh saya tahu.
Instrumental.
Dalam subjek instrumental. Okay. So basically, we are going to, apa tu orang kata tu, kita akan recap back apa yang kita dah belajar dalam instrumental analysis. And then kita akan go into depth kepada instrument to itself lah. So basically by the end of this course, you should be able, for me yang handle GC, you should be able to handle GC on your own lah. Kita kata sebagai competent enough untuk you guys handle the instrument. Okay. This course was supposed to be paired with hands-on juga, hands-on session. Means that, okay, you dah belajar gedebuk-gedebak, you dah belajar the theory and everything, and then you go into the lab and you get your hands on the instrument. You can try to operate the instrument yourself. Tetapi as you know that, you guys dekat rumah ke ataupun dekat campus?
Ada beberapa orang dekat kampus, Doktor.
Ada beberapa orang dekat campus, ada beberapa orang di rumah. So maksudnya for us to give you the exposure on the hands-on, maybe belum lagi lah, but we'll see on the next few weeks if there is some changes. But for now, it is better for you just to get into depth on the instrument itself. Okay, so for me, I will be handle GC for maybe these first 2 weeks. Maybe after this, I think that there are 2 more instruments, which is ultra HPLC, and then you will also learn about AAS, atomic absorption spectroscopy, from, if I'm not mistaken, from Dr. Razali. Okay, so by the end of this course, you should be able to say that you are competent enough to handle these 3 instruments lah. So basically GC, HPLC and AAS. So that's the aim and objective of whatever that we are doing, because we know that you have learned everything before this in instrumental analysis, ataupun kalau AAS tu kita belajar dekat dalam yang spectroscopy punya kelas. But for this one, we need you to, apa yang kita try to design adalah, we try for you to get your hands on the instrument. So you boleh guna, you boleh, apa orang kata tu, tweak everything inside the instrument so that you will become much more competent lah. Okay, that's the aim untuk this course. Okay, so for me, this is GC, gas chromatography, and I'm just going to go through the theory and everything, maybe for this first, maybe Untuk hari ni maybe we just do 1 hour, 1.5 hour only lah. But we'll see next week. Maybe if we don't achieve our target, maybe next week kita kena buat 2 jam penuh lah. Tapi I know that sometimes it is better to have some break in the middle. But yeah, we'll see how. Okay. So I'm not sure whether you knew or not, but I'm Dr. Ashraf. So I'm a new lecturer here at Jabatan Kimia, Fakulty Science. So I had just reported duty last December. Okay, so before this, you learn about GC from, if I'm not mistaken, from Dr. Amy, isn't it? Dr. Amy or Dr. C?
Amy.
Dr. Amy, yeah. So basically, whatever the material that I have now is from her lah. So basically, kita tak lari jauh lah daripada apa yang dia telah ajar dulu dengan apa yang kita akan recap sekarang. So basically, apa yang saya buat ni just recap sahaja, and maybe we can go into depth sikit lah tentang beberapa perkara. Okay. So let me share my screen. Okay, nampak ke skrin saya?
Nampak, Doktor.
Okay, alright. So, how am I going to conduct this lecture is that maybe if, kejap ya, I try admit seorang lagi. Okay, what I'm going to do is that I'm going to give the lecture, but at some point I will try to see whether you have questions or not. But if you have question, just open your mic and just ask me your question, because when I'm presenting I cannot see whether there are question inside the chat box ke apa ke. So maybe if one of you can try to see if there are question, you can just open your mic and ask a question. Okay. Alright, so okay, so let me, alright. So this course is called Instrument Competency. So I will handle GC, gas chromatography. Okay, so in this lecture, we will be focusing on some part of it, which is, okay, we will be focusing, you will have some sort of like introduction to the GC. This is like the repetition of whatever that you have learned in instrumental analysis. And then we will go depth into the instrumentation part, the injector, the oven, and also the column. So basically, these are the important thing lah yang kita try untuk discuss. Kita nak try tengok the instrument tu sedetail mungkin. Okay. So basically kalau kita tengok GC, you guys pernah tengok GC ke sebelum ni? Pernah tengok tak? You guys pernah operate GC tak?
Tak pernah.
Tak pernah Pernah tengok tak GC tu macam mana?
Tak pernah.
Tak pernah, okay. Oh, you guys, yelah dah lama kan, 1 tahun kan? Okay, so basically, okay, apa yang I boleh buat adalah macam ni. So GC tu sebenarnya bentuk dia ada kot gambar bawah ni. Tak apa, kejap. Okay, I just tunjuk je dulu. Okay, GC tu sebenarnya bentuk dia macam satu kotak sahaja. Okay, so I put here GC. Okay, so atas ni akan ada satu injector yang mana you akan masukkan you punya sampel. So dalam GC ni secara umumnya kita akan ada column. So mana it means that the sample will flow into the column, and then it will separate in the column. Whatever that we are going to learn akan happen dalam column itu, and then it will be detected by a detector lah. Basically itu bukanlah, yelah secara simpelnya kalau saya nak put what is GC? GC is the analysis, kita analyze sample yang mana kita akan ada column untuk separate whatever sample yang kita nak analyze tu. Okay, so atas ni akan ada injector port yang mana kita injectkan sample. So there is oven here yang mana oven tu will house the column because the column it will need to to maintain the temperature at certain temperature depend on the program, and then we will have the detector. Salah. Okay. Okay, that is the simple way that I can put what is GC. So we will be going into depth on what each of the, okay, we are going to go into on the injector. Apakah itu injector? Macam mana bentuk injector itu? Macam mana bentuk oven? Macam mana bentuk column? And what is the detector? So basically we are going part by part lah kalau you nak tengok macam tu. Okay, so these are the comparison of chromatographic techniques that we have. I mean that applies chromatography lah, which is separation. So the main thing that we are going to learn adalah gas. Supercritical fluid ni basically apa yang boleh kata CO2. Kalau you remember dalam I think dalam basic chemistry ke, you would know that carbon dioxide dia boleh jadi fluid, kan? So basically supercritical fluid ni employs kita menggunakan carbon dioxide sebagai fluid. Untuk separation itu berlaku. Kalau liquid ni, liquid chromatography ni yang macam kita guna thin layer chromatography, kita guna size exclusion chromatography, but the one that we are focusing on is this GC, which is gas chromatography, where we have the sample would also be liquid ataupun solid lah. Tetapi kita akan fokus on liquid punya part yang mana kita akan ada column and then gas liquid chromatography lah. So basically these are yang kita apa kata tu, the one that we are focusing on in this lecture. Okay, so alright, so as I mentioned tadi, so basically GC tu kita akan ada injector kan, injector kat atas ni untuk kita injectkan sample. So basically akan masuk ke dalam oven. So kotak ini kita boleh kata sebagai oven lah, oven untuk maintain temperature of the column. Column ni dalam oven lah. So for example, column ni kita letak 250 Celsius. So the sample from the injector will flow into the column and then it will be detected by a detector. So dia akan keluar result seperti chromatogram inilah. So contohnya dia akan keluar dekat apa tu? At our computer, it will come out as chromatogram, which is something looks like this. Something like this lah. So each of these represent one component lah. So separation had happened inside the column. Okay? Setakat sini faham tak? Ada apa-apa soalan? Faham tak? Hello? Faham.
Doktor.
Okay. Because this is something yang you dah belajar pun sebelum ni. Okay. So gas chromatography is forces that increases solubility of analytes on the stationary phase. So it depends on Roots law, but I will not go into depth on this Roots law because maybe this has been covered inside your instrumental analysis. So maybe we can skip this one because I want to focus on the instrument part. Okay, so sorry. Okay, so GC instrument samalah when mention as what I mentioned above. So injector kita akan ada oven yang mana in the oven we have the column and detector. Okay, now I would like to introduce you to the carrier gas. Okay, so carrier gas is something that will act as a mobile phase. Mobile phase ni adalah something yang will move and then will become mobile where it carries your sample. you know that separation would happen on two benda kan. Maksudnya separation would happen on the interaction of the analytes, the interaction of the analyte with between stationary phase and then mobile phase. Betul tak? Okay, so separation will happen when the analyte interacts with stationary phase and mobile phase. Okay, so now the mobile phase in GC is the carrier gas. Okay, carrier gas ni usually macam hydrogen ataupun nitrogen ataupun helium. Okay, so all of these gases will act as the mobile phase, which when we inject sample here inside the injector, so the sample will be carried into the column kan. So this gas lah yang akan carry the sample into the column. Okay, kejap. Macam ada orang keluar nak masuk. Okay. Okay, so this mobile phase, which is hydrogen, example hydrogen, nitrogen or helium, will carry the sample that we have injected into the injector into the column, where in the column we will have the separate stationary phase. So our sample will interact with stationary phase here that will create separation. Sebab separation itu berlaku di dalam kolom ini, yang mana interaction between the analyte and the stationary phase will create this this data, yang mana okay, siapa keluar dulu, okay, this is the first one and the second one, the third one. Okay, so in GC, basically what is the important thing is that you know that the mobile phase is gas, which is in this case, for example, helium, hydrogen, ataupun sometimes it is purified air. Purified air. Okay. So the important thing is that mobile phase adalah gas dan stationary phase adalah solid lah. Di dalam kolom ini, we will look at shortly, where there are solids. So the analyte in the sample yang kita dah inject ni will interact with the stationary phase. Sama ada dia nak stay lama dengan stationary phase ke, ataupun dia nak stay sekejap sahaja dengan stationary phase ke. So these different properties lah, we can say that these different properties of analytes inside the sample will create this profile, yang mana for example, siapa yang keluar first ni, so analyte yang keluar pertama ni mestilah keluar awal kan. So maksudnya bila kita detect dia keluar awal, dia spend time dekat dalam stationary phase ni kejap sahaja. So siapa yang keluar lewat tu, maksudnya for example yang this one, dia punya time lagi lama lah. Maksudnya it spend time more inside the stationary phase, inside the column. Okay? So kat sini faham?
Faham, Doktor.
Alright. Okay. So these are the example. Kita boleh tengok GC instrument lah. Tadi siapa yang kata tak pernah tengok GC instrument. So these are the example of GC instrument. So this is okay, I tengok yang ini dulu Okay, ini adalah injector port. Ini adalah injector port yang you nak masukkan sample. So inside this syringe, we have our sample. We have our sample for the separation inside this syringe. So you can see that this syringe pun dia punya dia punya jarum pun memang very small. Sebab nak fit into this into this injector punya port, because it's small. Okay, so this is the injector which usually located above, which is on top of the instrument lah. Okay, this is the column. Ini adalah oven. Kan yang tadi tu saya kata yang kotak tu. So this is the oven where it house the column. So this is the column. Ni adalah column where the separation happens. So bila kita injectkan sampel dekat sini, yang ini injector, kita inject sampel dalam ni. So sampel akan flow through inside the column. Column tu kadang-kadang ada yang 60 meters, ada yang 30 meters. So this perbezaan properties pun akan effect lah kita punya result. Okay, so here you can see there is a gas here. So this is, I'm not sure what this is, maybe helium code. So this gas will act as the mobile phase, which will create, which will carry the sample that we have injected into the column. And then inside here, in the column itself is the stationary phase where the separation happens, and then the data will go out into the detector. Sekejap ya, ada orang lagi nak masuk. Okay. So this is also GC. I think this is GCMS. Here you can see the tall thing here is the auto sampler. Okay, what do you mean by auto sampler? Auto sampler ni is something that we attach to the injector. So bawah ni ada injector sebenarnya. Here ni, kat bawah ni ada injector. Okay, so maksudnya auto sampler ni kita letak je sampel kita, dia akan injectkan automatically untuk kita based on our our sequence. So maksudnya you tak perlu berada di depan GC ini. For example, kalau you do project yang menggunakan GC, you tidak perlulah inject manually. It will be injected for you. So you prepare the sample, you put the sample inside the auto sampler, and then you will create some sort of like a sequence. So they will analyze it according to your sequence automatically. Tetapi kalau you guna this manual injection, you need to be there lah. You need to be there to do the injection yourself. Sekejap Okay, so ada korang dah start buat PSM ke belum lagi? Tahun 3 belum
Belum, Doktor.
Belum. Okay, so in the future nanti tahun depan bila masuk tahun 4, bila you guys buat buat PSM and guna GC, you will see this lah. So usually kita akan try to look whether you can do the manual ke tidak lah. So selalunya kita akan buat manual dulu sebab yang auto sampler is quite expensive. So for example, okay, let me put into perspective. This GC, katakanlah kita kata GC sahaja ya. GC sahaja berharga 300,000. Okay, 300,000. Alamak, apa tak ni? Okay, 300,000. So it's quite expensive, just the GC. The auto sampler adalah 50,000. So kalau universiti yang kaya, dia akan ada auto sampler banyak lah. Tapi untuk basic kita akan buat injection ourselves lah. We can save a lot of money. Tapi it comes in different when in research. When you want to have like a precise punya result, you need to use auto sampler because auto sampler kan machine yang mana dia punya error tu lagi kurang lah. Macam kalau bila you inject sendiri, kadang-kadang okay, kadang-kadang tak okay. So it depends on you punya apa orang kata tu, yourself punya skill lah. So that's why this course is created specifically untuk tahun 3 supaya when you go into tahun 4, you when you need to handle the instrument, we already know that you are competent. Walaupun kita still ada guidance, tetapi you tak adalah buat kesilapan-kesilapan yang kurang bijak yang akan contohnya merosakkan GC ke apa ke kan. Merosakkan instrument lah basically. So that's how we look at things lah. Okay. So it's good if you have this course tahun 3 and it's still fresh with you kan, because you baru learn about for example GC ni semester lepas baru belajar. Semester lepas ke semester ni GC? Hello?
Sem lepas ada learn yang basic saja.
Okay. So semester lepas you dah belajar GC, so semester ini pun you belajar GC lagi. So okay lah, I rasa it should be fine. Okay. This is the GC gas line configuration. This is something that is in my opinion is not that important for you. It is just that what you need to know is whatever gas that has come out from the cylinder will be, apa orang kata tu, it will be filtered. For example, alah, kenapa pula ni? Tak ya. It will be filtered lah. So it will be filtered using hydrocarbon trap, molecular trap, oxygen remover and line filter. So basically whatever that has been gone into your GC would be memang ultra pure lah, because we have filtered using hydrocarbon trap. So katakanlah carrier gas to U2 atau mobile phase U2 have some carbon, it will be trapped here, and then kalau ada benda-benda bendasing which is yang besar-besar tu, it will be trapped in this molecular trap. And then we also remove oxygen because we don't want oxygen inside the line. If not, combustion will happen lah, because you ada oxygen and then GC itu sendiri panas. Kan I said that the oven itself can, for example, it can go up to 250 Celsius. This is the normal temperature, but it can go up to 350 to 300. It depends on the GC. So that's why we really need the oxygen to be removed. And then we also have a line filter here. Okay?
Doktor.
Yeah.
Sorry nak tanya. Just now, kalau kita kalau kita manually inject the sample, apa yang perlu kita buat atau tak boleh buat semasa buat injection?
Okay. That's a good question. Thank you. What's your name? Sorry, can I know?
Michelle.
Michelle. Okay, that's a good question, Michelle. Okay, during injection, what you need to, first of all, this is my experience, okay? What you need to do is that you need to have very steady hands. Okay, the skill of having a steady hand, because this injector would be set at 250 Celsius. So you can imagine how hot the injector would be, because you would need the sample to straight away evaporate inside the injector. Kita tak mau dah because you apa yang you inject ni is liquid. So we need it to straight away being evaporated, vaporizes, and move into the column. So that's why we set it at a very high temperature. So what I mean by steady hands, that's the first thing, because you encounter something that is very hot. It's not that hot. For example, for this distance, it's not that hot. Tetapi bila you berhadapan dengan something yang very panas, you know that it's quite hot, then yelah, you akan rasa takut sikit lah. So that's why that's the first thing. The second thing is that for you to have a steady hands, because this needle is very thin and senang patah. Because to fit into the apa orang kata tu, into the injector ni, you need to your syringe here need to be perpendicular. So for example, this is the pot, it need to be straight. Tak boleh sengit. Kalau sengit nanti dia patah. So that's the reason number 2 lah, for you to have a steady hand. And then pula the second thing, the third thing is that bila you masukkan, bila you masuk syringe and you nak push the sample, kan, bila you nak push the sample tu pun you need to push in a straight, apa orang kata tu, swift punya motion, just straight away insert the sample. Because kalau you masuk sikit, dia akan evaporate sikit-sikit lah. So bila evaporate sikit-sikit, and it will affect your result. So that's why some I think that most of kalau research punya wise, kita akan guna auto sampler, because auto sampler does not have that problem of become steady, of you having a steady hand, because it's already steady, is an instrument. So the rate of injection pertama dengan injection kedua pun sama dia punya rate. Kalau kita manusia, bila kita nak inject pertama tu mungkin ambil masa sikit, injection kedua tu mungkin lagi perfect. So that's the thing lah that you need to be careful of. So yeah.
Kalau itu string dah patah macam mana?
Okay, syringe dah patah macam mana? First of all, that's the thing. Syringe is quite expensive.
Hello?
Dengar ke?
Dengar. So
the syringe tu expensive. That's the first thing. Kalau syringe patah, so the end of it tu akan berada di dalam injector. So you need to open the injector port and bawa keluar balik benda tu. So it will, orang kata apa, it will habis masa kat situ sahajalah. Because this instrument you need to book first. So nanti bila you buat PSM, katakanlah you encounter with GC, and then you will need to book. I think that kalau GC memang very popular, maybe you need to plan ahead, maybe 2 or 3 weeks ahead, and you go book them. So bila you inject and something happen, so that's the thing, you need to nak baiki balik. Itu kalau problem-problem macam syringe ni, which is for me syringe problem ni is masalah kecil dalam GC. There's a lot of other things that akan menyumbang kepada permasalahan. So for example, you punya detector tak boleh detect. That's something is very big, because you need to change the whole detector. That is going to take some time. So that's the thing. When you learn about this subject, you would know. Oh, okay. I've learned that bila guna injector ni, you need to have steady hand. So you straight away kena you can beware of whatever that is going to happen lah kan. So because whenever that you learn inside the instrumental analysis, it is for to introduce you to the GC. So in this course, you will learn on how to operate. What are the tips, the tricks on to use the GC? That's the thing lah.
Okay. Thank you, Doctor.
Alright. Thank you, Michelle, for the question. Okay. So now I will play a video. This is Dr. Emmy's punya student lah. So maybe I can play it here. Okay, boleh nampak ke video ni? Semua nampak tak video? Boleh. Okay, alright. So I play. Kalau tak dengar suara, just unmute yourself and cakap tak dengar suara, okay? Alright, so that is some of the explanation on. Oh, tadi semua tak dengar ke? Hello?
Tak dengar tapi okey je Doktor.
Oh, tak dengar eh. Okay, sorry. Okay, tak apa. I will give you the slides later on, and then you can see the back the video lah. Okay. Sekejap ya. Okay. So now, as I mentioned earlier, we are going to learn part by part. Kan? For the instruments, we are going to learn about the carrier gas. Okay, so this is the first part, the important part, which is carrier gas as the mobile phase. And then you would see that after this, we will go into the injector. Which will we will explain on the split or splitless, and then after the injector we should go into the oven. We should go into the oven, what the oven do, and then we'll go into the column, if I'm not mistaken. Yes, GC column and stationary phase. And then lastly, we will go into the I think it was supposed to be a detector. This is all the explanation of column. Detector ada tak dalam ni? Yes, so the end is detector. Okay, so we are going part by part lah. Okay. So, ada question tak on pasal previous punya ni? Sebab sebelum saya mula dengan carrier gas, is there any question? Hello? Tak ada. Okay. Alright. So, carrier gas. So, as I mentioned earlier, what the important thing, kalau you ingat GC, straight away GC mobile phase dia adalah gas, stationary phase dia adalah solid. So this carrier gas will act as the mobile phase, which in this case mobile phase ini hanya tugas dia adalah hanya membawa sampel ke dalam kolom untuk dia separate di dalam kolom dan membawa kepada detector. Tugas dia ada untuk membawa sahaja. Whereas kalau nanti the next instrument HPLC, mobile phase ini bukan sahaja membawa, tetapi dia juga akan ada some sort like affinity towards you punya analyte. Maksudnya dia akan ada effect kepada analyte you. Okay, separation ni kan macam mana I nak put in a simple way separation happens ni. Okay, separation kalau dalam GC, as I mentioned kan mobile phase ni hanya membawa sahaja. So mobile phase ini tidak akan affect you punya sample. So sample ni, separation happens inside the column. The stationary phase ni lah yang akan affect you punya analytes di dalam sample tu. Okay, contoh dekat dalam satu sampel ni ada 3 analyte. 3 analyte yang ada different property. Okay. So these 3 analyte akan react differently kepada stationary phase. Bila dia react differently kepada stationary phase, that's how separation happens. This react differently ni would depend, for example, kalau tengok dalam video tu tadi, the first number one property adalah polarity. Means that the analyte yang keluar dulu tu polarity dia tak sama sangat dengan stationary phase. So sebab tu dia tak duduk lama dalam stationary phase. Kalau yang duduk lama dengan stationary phase, dia punya polarity tu sama dengan stationary phase. So that's how stationary phase ini create a separation. Okay, faham tak itu?
Faham, Doktor?
Faham. Okay, good. Alright.
Sorry, Doktor.
Yeah.
Tanya kalau yang stationary phase dia sama, so kita perlu choose punya stationary phase is more polar or less polar, or I mean the polarity.
Sorry. I tak dengar putus-putus. Apa tadi?
Kalau kita nak test itu benda, kita guna punya polarity should be very high polarity punya stationary phase ke?
Okay, for the stationary phase, kita memang ada banyak jenis polarity daripada polar ataupun daripada yang paling polar ataupun yang paling non-polar. So we have a lot of types of stationary phase. So it will depend on your sample. So for example, okay, your sample tu macam okay, tak boleh lah you punya column tu polar tapi you punya analyte yang you nak separate tu non-polar. So non-polar dengan polar dia tak sama polarity. So dia akan keluar terus, dia akan elute terus. Dia tak akan duduk langsung di dalam column itu. So you would need to find a column that can separate tetapi tidaklah terlampau, apa orang kata tu, contohnya you punya sampel tu non-polar and you cari column non-polar juga. So nanti sampel tu tak akan keluar. Sebab dia nak duduk dekat dalam kolom sahaja, sebab dia punya affinity tu kita kata kalau dalam analytical chemistry there is a principle of like dissolve like, means that non-polar would dissolve non-polar. So in this case, bila you punya sample tu non-polar, you cannot have a non-polar punya column. You would need to have some polarity to it. So contohnya you kata you ada non-polar punya sample, you punya column would need to be, for example lah, you kata okay, saya nak 80% non-polar, 20% polar. So bila that mixture ada, yang mana you ada 80 non-polar and 20 non-polar, 80 non-polar, 20 polar, so it will create different properties lah. Maksudnya some analyte would be keluar awal and some analyte akan duduk di dalam itu lama sikit. So it depends on your sample sebenarnya. I menjawab soalan you tak?
Maybe I'm not sure lah. Just so kita dah boleh choose yang sama polarity with the sample yang kita ada lah.
Kita boleh choose sama polarity tetapi tak boleh terlampau sama sampai nanti dia tak akan keluar.
So tak boleh too far, tak boleh too close, something like that.
Maksudnya you need to find something that is in the middle. Tetapi macam ini, okay. This column ini telah dimanufacture oleh company-company yang apa orang kata tu, company-company besar lah, Agilent, Shimadzu, apa semua. For example, I ada sample oil. So I nak guna column apa lepas tu dia akan kata okay, nah guna column ni. So you don't need to think. So column yang dia suggest itu, column itu memang sesuai untuk analyze you punya sample. So usually kita macam tu lah, when we have a sample, we would call the supplier, we would say okay, I have these samples which for example, I have fatty acid punya sample, I have lipids punya sample. So I nak guna column macam mana? So they will give you a column, tetapi you would see that the column would correspond to your analyte. Maksudnya bila you tengok property column tu, oh column ini pun ada non-polarity dia quite high juga. Sebab you punya sample tu non-polar. Macam tu.
Oh, okay. So
Alright.
kita see the manual atau kita tanya lah.
So it depends. For example, kalau nanti bila you, yelah kita go melihat jauh lah, bila you go nanti into research ke apa ke, bila you kerja ke, okay, you have this sample, I have this fatty acid methyl ester sample. So you contact supplier akan advise you on which column is the best for your sample. And when you see the properties of the sample, you would see that it corresponds to what you know lah. So the sample kalau non-polar, dia kena ada non-polar sikit supaya kita akan achieve separation. Tetapi tak bolehlah non-polar itu 100%. I tak rasa, I tak pernah jumpa lagi column yang 100% non-polar ataupun 100% polar. They must have some combination of between polar and non-polar because we want to achieve that separation. Okay?
Okay, thank you.
Alright. Okay. Kejap Okay. Okay, so I will continue with carrier gas, which is the mobile phase. Okay, as I mentioned, the mobile phase would need to just carry the sample into the column, kan? So bila maksud I carry and dia tak ada effect kepada you punya sample, so this is what I meant. It is chemically inert gas. Maksudnya carrier gas ini must be chemically inert. That's why the carrier gas used is helium, nitrogen, purified air. something that is very inert where it will not affect your sample. So tugas dia hanyalah membawa, carry sahaja sampel itu ke dalam kolom. Okay? And then it says here that the choice of gas is dependent upon the type of detector. This kita akan tengok into depth lah when we go into the detector. But usually, the gas of choice will be helium, nitrogen and purified air lah, hydrogen, macam tu. So the system contains a molecular sieve to remove water and impurities. That is what I have explained earlier, this one. So we have the hydrocarbon trap, molecular trap, oxygen remover and line filter. All of this to make sure that whatever gas that are flowing into your GC is pure as possible and free of contaminants. Okay. These are the example of carrier gas are nitrogen or helium, and then these are the flow rate. Means that if we are using capillary column, usually the flow rate is 1 or 2 mil per minute. For example, if we use packed column, the rate is much more higher lah, 40 mils per minute. Okay. Detector gases, which are hydrogen and air. So the gases also would supply to the detector, because for example detector, nanti kita akan tengok, you would see there is one name of flame ionization there is FID. So flame ionization detector. So flame means that it will need hydrogen and air to create the flame. So whenever the sample arrive at whenever the analyte arrive at the detector, it will be terbakar lah, because there is presence of flame. So whatever terbakar itu, the molecules ataupun the atoms yang ada kat situ tu will be detected, and then it will come out as a chromatogram lah. Okay? So are you guys clear on this carrier gas? Clear tak?
Clear.
Okay. Alright, good. Thank you. Alright. So after the carrier gas, we will go into the injector. Okay. Injector ini adalah something that is important lah, as I mentioned. It will straight away being set at a very high temperature, because we want your sample to evaporate straight away inside the injector. And then the injector is also can be used manually, as you've seen, and then it will also be done automatically using an autosampler. Okay, what is an injector? Injector is a hollow heated glass lined cylinder where the sample is introduced into the GC. So this is the first part of where the samples are introduced. Okay, a micro syringe. So the syringe, based on the video tadi kita tengok, syringe tu memang sangat kecil, dan dia punya amount pun we can go as as small as 1 microliter. Okay, memang very very fine punya syringe, and it is a glass lined cylinder lah, because we don't want anything to happen to the injector. Okay, so a micro syringe is used to inject the sample through a rubber septum into a flash vaporizer pot at the head of the column. Okay, boleh tak I tanya, kenapa kenapa rubber septum ini sangat penting? Ada siapa-siapa boleh jawab? Tak apa, salah pun tak ada masalah, kita berbincang je. Why we need to have a rubber septum dekat injector ni? Kenapa? Kenapa perlu ada septum? Septum ni. Septum.
Manage the pressure. Control.
Okay. Manage the pressure also good, because the gas here kan carry gas masuk ke dalam sini. So kita nak make sure that the pressure dekat dalam ni pun tidak hilang. Okay, ada lagi answer lain?
Avoid itu gas vaporize out.
Okay, avoid gas vaporize out pun a good answer. So the other thing is that we want to make sure that bila kita insert sample, and kan I kata sample itu terus vaporize di dalam injector ini, kita tak mau sample tu keluar balik. Bila kita dah inject masuk and it vaporize tu jadi gas, so kita tak mau dia keluar balik daripada injector ni, sebab tu kita ada septum. And your answer is also correct. We don't want the carrier gas to go out of the injector. Okay, so that's why we have this rubber septum. Rubber septum bila kita inject atau bila kita cocok, it will close back, kan? Tapi bila dah banyak kali cocok, it will become tear lah. So that's when you need to do your maintenance lah. So this is the first thing. For example, nanti bila you buat bila you buat you punya eksperimen PSM ke apa ke, you get result yang sangat rendah walaupun you inject standard. You inject benda yang you tahu bahawa dia punya concentration is very high, tapi kenapa result you sangat rendah, macam sampai tak boleh detect? You will need to check your septum first, because sometimes bila terlampau banyak kali cocok, usually it will have a reminder. For example, for one septum, I think that is about 100 injections sahaja per septum. So dia selalu ada reminder lah, tapi this is the first thing that you need to see. If you have a sample ataupun result yang very low, walaupun you tahu dia punya result tu sepatutnya tinggi tapi dia rendah. So this might be one of the problem lah. So maybe the septum dah terkoyak ke sampai you punya sample terus tak ada di dalam injector ini. Sebab carrier gas ini hanya akan membawa sample you ke dalam. Maksudnya apa-apa sampel yang berada di sini akan dibawa ke dalam kolom. Kalaulah you punya septum ini terkoyak or being broken or something, then it will flow out back. So there is no chance for your sample to be carried into the column. Okay? So that is the first tips lah yang I boleh bagi. Maksudnya in terms of whenever that you face the instrument nanti, you will see that okay, the first part of maintenance adalah septum dan juga liner ini. You see the liner? Liner inilah yang glass liner ni. So glass liner ni usually di dalam ini kita ada cotton, glass wool, where kadang-kadang bila you dah inject terlampau banyak, you dah inject terlampau banyak sampel, septum ini akan perlu ditukar dan juga liner ini perlu ditukar. Sebab sometimes the sample dia akan accumulate dekat sini. Sample ni accumulate dekat sini, dekat glass wool ni sampai glass wool you ni hitam, and then you would get a very bad result. You would get results that that is not even your result. So that's the thing lah. Faham tak?
Sorry doktor. Nak tanya kalau kita nak tukar, kita tukar itu glass wood atau itu glass liner?
Okay, kalau nak tukar, usually it will come as one. Maksudnya liner ini usually it will come dengan glass wool di dalam dia. So you would need to just change the liner lah. So I think maintenance should be like 2 or 3 months. It depends on how frequent you use. So septum and liner would need to be changed sekali. Maksudnya katakanlah lepas 100 injection, you will need to change both lah. Because when you open it, you will see that this glass wool and liner ni akan jadi hitam lah.
Oh, okay. Thank you, doktor.
Okay. So after the injection, the sample forms a mixture of carrier gas, vaporize the solvent, and vaporize the solutes. Okay. So that is what I said lah. When you insert your sample, and then it will be straight away vaporized. Temperature of the sample pot must be, okay, this is important. The temperature of the sample pot, this injector ni, must be 50 degrees higher than the boiling point of your least volatile component. Okay, what does it mean? Okay, you ada, okay lah, I bagi benda yang simple lah. You ada dua sampel, you ada dua analyte di dalam satu sampel itu. Dua analyte, yang mana the first one, analyte itu dia punya boiling point adalah 30 Celsius contohnya. The second one, the analyte is 50. The boiling point is 50 Celsius. So what is the temperature yang you need to put for your injector? Any guess?
100.
Yes, 100. So it needs to be 50 degrees higher than your least volatile. So in this case, the first one is volatile enough. Means that dekat 30 terus dia punya boiling point 30, so dia terus vaporize. Tetapi the second one is your least volatile, which is 50 Celsius. You know the boiling point. So your sample pot temperature will need to be 100. That's the rule lah. But usually in real life, we would set the injector for some times it is 150 Celsius, 250 Celsius. Okay. The purpose of it when we put it at very high temperature is that we want to make sure that your injector semua ni is free of any analytes. Means that, okay, katakanlah, bila you buat PSM nanti, bila you handle GC, hari ni you guna, semalam kawan you guna. Yesterday when your friends use the GC, they analyze sample at, maybe dia punya sample tu the least volatile is 150 Celsius. So kawan you semalam set 200 Celsius lah dekat injector ni. So dia pun dah habis dapat result. So today you nak analyze. And then you set at 100. Sebab sample you 100. Sebab sample you paling rendah 50 kan. So you set 100 Celsius. Tetapi maybe inside the injector itself ada remaining of your friends punya sample. So bila ada remaining, because yelah this liner ni pun bukanlah kita selalu tukar. Maksudnya tak boleh lah per analysis tu we need to change the liner, nanti habislah. So bila you set at 100, ada kawan you punya semalam ada remaining dalam ni. So the yang sample yang semalam itu akan affect you punya sample. Because sample semalam, sample kawan you semalam yang 150 tu di dalam ini dia akan exist as liquid je lah. Sebab you set at 100, you punya sample memang dah vaporize dah. Kawan you punya sample tu ada dalam ni as liquid, which is akan effect lah kepada you punya sample, betul tak? So that's why we usually put it at macam 150, 200 Celsius, 250. So we want to make sure that we want to make sure that the injector ni as clean as possible lah. So that is another thing that when you do your project nanti, injector ni kalau you put at 150 ke 200 ke, it should be fine lah. Tak adalah ada isu tentang nanti sample you hilang ke apa ke tidak. Sebab sample tu still vaporize. Tetapi kita try untuk make sure maintain temperature tu supaya it is free of other contaminants lah. Okay, setakat situ okay tak semua? Is there any question? Ada question tak?
I think no, Doctor.
No, okay. Alright, good. Okay, split list ni, I think that I will need to cover. Okay. sebab I perlukan masa untuk splitless ni. Okay. Tak apa, I masukkan je kejap. Okay. Split injection. Okay. Your injector would need, nanti you would know this. Okay. Your injector would have two modes, which is split modes and splitless mode. What does this split or splitless mode means? And how can it affect you punya sample? Okay, split. Split ni kita boleh kata it's the simplest method. Ideal if only a small number of components present, not for trace analysis. Okay, this is important. Not for trace analysis. It is a mode split ini, split injection ini sesuai digunakan untuk sampel yang bukanlah begitu trace amount. Maksudnya trace amount tu yang sangat sikit lah, sebab kalau trace amount we straight away use splitless. Tapi split ni kita selalu guna untuk sampel yang concentration dia agak tinggi. Okay, so how would you use split injection and what does split injection means? Okay, macam ni. Okay, for example I cerita dekat you benda yang senang nak faham lah. Okay, katakanlah you ada 100 molekul di dalam you punya sampel, 100 molekul Okay, you ada 100 molekul and then you set the split injection ini kepada 99/1. Okay. You ada 100 molekul, you set the split injection to become 99/1. This ratio will apply to your injector port where 99 ni akan dikeluarkan daripada GC. Satu sahaja yang masuk ke dalam kolom. Okay? So 99 part daripada 100 ini akan dikeluarkan daripada GC. Maksudnya dia evaporate, tetapi dia akan diventkan keluar daripada GC. Hanya satu bahagian sahaja yang akan masuk ke dalam GC. So that's why we say that this split injection is not advisable kepada trace analysis. Sebab contohnya kalau trace analysis amount dia tu tidak akan, macam it will not be detected lah when you use split. It is usually kepada sampel yang concentration dia agak tinggi, yang mana kita tak perlu pun concentration tinggi-tinggi tu. Asalkan satu ini dah boleh cukup untuk menghasilkan result you, boleh quantify and boleh identify, 99 ni keluar je lah. Sebab kita pun tak mau memburdenkan kita punya kolom untuk analyze 100 molekul. Kita kalau boleh, kalau satu ini boleh untuk di-analyze, dapat result apa semua, kita use satu sahaja. Kita tak perlu pun 99 ini. Tetapi untuk trace analysis, yang mana contohnya dalam trace analysis tu you ada 2 sahaja molekul. Tapi you buat 1:1. So tak boleh lah. So untuk trace analysis, dua-dua ni kena guna splitless injection. Okay, kalau bila I cerita macam tu, you faham tak apa maksud split ni? Kita splitkan molekul tu, faham tak?
Faham.
Faham.
Doktor,
Ya.
Kalau ratio dia 1/1 means dia is the splitless. Kalau dia ratio ada means dia split macam tu lah.
Tak. Hanya split sahaja yang ada ratio. Maksudnya splitless ni memang tak ada ratio lah, because 100%. So these two, katakanlah trace analysis kan, contohlah. This is just analogi sahaja. So katakanlah for trace analysis you ada 2 molekul sahaja. So these 2 molekul would 100% akan masuk ke dalam kolom.
Oh, so satu punya ratio means half of it will go out.
Maksudnya kalau 2 ini, these 2 molekul ni, kalau you buat split injection, you would apply this ratio, satu masuk, satu keluar.
Oh,
So bila satu masuk satu keluar, satu itu adakah cukup concentrated untuk be detected? Sebab kita punya concentration sangat sikit, yang mana bila di trace analysis, kalau katakanlah you buat research nanti, you punya sample itu adalah trace sample, so you straight away go to splitless. Don't even think about split injection. Because split injection ni kita akan keluarkan the majority of your sample. So for example, kalau you tengok ni, typical ratios 10:1, this is the ratio. So dari 10 bahagian daripada sampel you akan dikeluarkan, hanya satu bahagian sahaja yang akan masuk ke dalam kolom. Kalau 10:1 dengan 51 ni, 51 ni lah lagi banyak pembahagiannya, betul?
one more question, Doctor. Kalau the sample is a unknown sample, kita juga akan choose splitless, betul?
Okay, usually unknown sample you would choose splitless because you would need to see first whatever that you are handling with.
Okay, thank you.
Okay. Ada question lagi tak tentang split ni? Faham tak tentang split? Okay, kalau tak ada berbunyi tu, I assume faham. Okay, so so typical ratio now, you see that 10 ratio to 1. 10 usually will the one that is going to be vented. One part of the sample will be inserted into the column. So there is also 50 ratio to 1. So only a small proportion of the sample is transferred into the column. So ni pun samalah, macam I kata, satu sahaja. So for example, when you see in journals, when they say that okay, our method employ split injection of using 50:1 ratio. So you automatically would know that 50 is bahagian yang akan di vented out, 1 will go into the sample, will go into the column. Sometimes in journals, they would not say we are using split injection. They would just say that injector is set at 50:1. When you see the number is like this, 50 ratio to 1 ke, 10 ratio to 1 ke, so straight away, or they are using split injection. Okay. So this is the example lah, in terms of gambar rajah. So the carrier gas would flow into the injector, and then this is the split vent. Yang mana your punya sample tu, katakanlah kita kata 10:1. So these are the tens. Ni yang tens. Yang 10 tu lah. Yang 10 yang nak dikeluarkan tu. Yang nak dikeluarkan. Yang satu itu yang inilah. This is the one. Yang masuk ke dalam column. So basically this is how it happens. Okay. Okay, splitless injection. Suitable for samples containing trace compounds. Okay. Trace compounds in low concentration, because it is necessary to transfer as much as possible. So as much as possible sample into the column to increase sensitivity. So when people ask you why you use splitless injection, straight away because my sample are in trace amounts. We want to transfer as much as possible sample into the column to be analyzed. Okay. So lower valve is closed at the injection, at the time of injection, and only a small of septum purge flow is used. injection usually take place in a heated zone over a period of 20 seconds so that all of the sample are being transferred into the column. After a predetermined period, the lower valve is opened to purge the injection port and to prevent residual samples from causing tailing of the peaks. Okay, this tailing of the peaks uh, are something that you will need to look at whenever that you see the chromatogram. Okay, maybe I can explain a little bit here. Okay, dalam sesuatu chromatogram, kalau GC ke HPLC ke, what you would need to aim is that you would need to aim for a very sharp peak. Ni pun tak very sharp sangat lah because dia nak turun naik pun tak sama. Okay, so basically you would need to aim for this. But sometimes you would receive ataupun you would the GC would produce something like this. Ataupun it will produce something like this. So this is not a very good peak lah. So that's why ada tailing ataupun fronting. This is fronting. This is tailing. Maksudnya it goes up instantaneously and then it goes down secara lambat lah. So means that this is the tailing of the peaks. So you would need to tengoklah benda-benda ni when you analyse your chromatogram. Okay? Alright, so this is the diagram for splitless injection. So you would see that all of the sample are going inside the column because we have closed the split vent. Kalau kat sini kita open the split vent and we set it to 10-1, so the 10 part of it will go out, only one part will go into the column. Where for splitless injection, we close the split vent. So it depends on you. It depends on your sample. What are the strategies that you would need to see? Okay, for example, kalau lah sample you to is quite high in concentration and you nak buat juga splitless. You nak buat juga splitless. So when you do splitless for a very high concentration, your chromatogram will be like this. Your chromatogram would have like some sort like a box figure rather than a very good peak. Because it means that your sample, all of your sample are being injected into the column and your sample is too concentrated. So when it is too concentrated, kita tak boleh achieve a very good separation and on top of it, kita dapat box yang kotak macam ni. So when you do splitless and you see this problem, you would straight away think that, oh, I need to do splitless because this sample is very concentrated. Okay, faham tak?
Faham.
Okay. Alright. So I think that maybe if do you guys have any other question? Because if not, I would end here lah because Avan nanti kita buat minggu depan. Ada question ke? Tak ada question eh? Okay, alright. So, okay, I stop presenting dulu. Okay, I just nak tanya, so this is the time where all of you are free lah? Or ada juga yang tak free pada waktu ini?
Saya free masa ni je, Doktor.
Okay, alright. So far waktu ini sajalah free kan? Okay, so in that case, maybe we will stick to this schedule. Okay, so if If we don't have any more question, maybe we can conclude our session today lah. Okay, so maybe next week we will continue on the oven and the other part of the instrument. Maybe I will go much more faster lah because all of that pun you dah pernah belajar dulu lah instrument analysis. So maybe some basic things telah di apa orang kata tu telah dibelajar dalam instrument analysis. I can skip that. Okay. So if there are no more questions, that maybe we can end the session. And if you do have a question after this, katakanlah bila-bila you teringat ada soalan ke apa ke, just hit me up on the WhatsApp group lah. So that everyone pun boleh belajar kalau you guys ada apa-apa soalan. Okay?
Okay, Doktor.
Okay, thank you, Doctor.
Alright. Thank you. Thank you guys. Thank you. Bye.
Thank you, Doctor.
Thank you, Doktor.